Hi everybody and welcome back to our ongoing tutorial series on creating a simple space shooting game. This week we are going to be doing some coding. We're going to start moving our player spaceship around. So let's get right into it. Before we start actually coding, let's talk about how that design is going to be and what this is going to look like. So let's just think real quick. What are some things that our various entities are going to do? And our entities in this game, if you recall from our 3D models that we created, we have a player spaceship, a regular bad guy spaceship, and then a boss spaceship that you'll fight at the end of the level. So I just want to really quickly go into what kind of functionality all these different things have. So we'll start with the player. The player needs to move. They need to take damage. Some parentheses will say, blow up after they take enough damage. And they need to shoot. So let's talk about the regular bad guys. So in these side-scrolling space games, regular bad guys need to move. They move in a pattern. They'll take damage. But they will not shoot. And then finally our boss, he needs to move. He needs to take damage. And he'll also be shooting. So what I want you to see here is that there's a lot of crossover functionality between our various entities that we'll have here. So let's see if we can kind of extract that. So above all these, let's think of a class called Spaceship. And so what Spaceship's going to do is it's going to move, and it's going to take damage. So then we can say our player is a spaceship. Same with our baddie, same with our boss. And that just leaves the player and the boss with a little bit of special functionality for shoot. So I'll say the player is a spaceship that can shoot, and boss is a spaceship that can shoot. So this kind of gives us an idea of what our classes that we're going to be setting up are going to look like. We'll get started by creating our overall spaceship class. Okay, so we're here in Unity. Let's go into our scripts folder. We're going to right click, create, and a C# script. We're going to call this script Spaceship. And let that load for a second. Just a brief aside while this is loading. If you're totally new to programming, I don't expect all this to make sense to you. Just copy what you see. What I'm going to try to show you here are some fundamental concepts. And if they don't make sense now, I promise, after you practice for a while, they eventually will make sense. But you'll be able to carry over a lot of the things we're learning about here into your own projects. Okay, Spaceship. So let's go back. As you recall, we have two functions we really care about here, which is move and a function called take damage. So we'll start with move. We're going to say protected override, virtual vector3 move. We're going to just return a vector3.0. And we're going to make another function called protected virtual void take damage. And we'll do int damage. And we just leave the body of that empty. So if we're taking damage, obviously we need to have health. So we'll have private int health. And 100 is probably fine. Let's make this serializable so we can set it from the inspector. Doing that wrong. Serialized field. Ugh. Okay. And we want serialized field speed. We'll call this move speed, not just speed, just to make it extra clear. We'll also have that be serializable. And then we're just gonna, we also want private bool M is alive. That'll just tell us if the ship is alive. So let's say private void start, maybe awake, say M is alive. True. So we're just going to initialize, make sure our health or our state is always starts out as alive. Let's actually change this from M health to M max health. And then we'll have another field, private health. Or current health. Better. So this way you set your max health to start with, and then the current health is going to track it from there. And actually, I don't think we want this to be virtual void. We're just going to do private void take damage here. And what happens in our take damage function is we take our current health and we subtract the damage amount from it. Trouble seeing my keyboard. There we go. And then after every time we take damage, we want to see our current health is less than or equal to 0. And then we set our alive. It's equal to false. And we'll probably change, we'll actually have like a function for dying because we're going to want to do something like play an effect or something when it happens. But for now, we'll leave it at that. This is all going to evolve as the project continues. Okay, so I think we have everything we need. There's one more function I want to add here, actually. So private void let's update. So if we're alive, we want to do movement. So I'm going to say var movement vector is equal to move. And then transform.position plus equals movement vector. That will move us around. Okay, so this is what's called a base class. So this class is going to be all of our spaceships are going to derive from this class, and that means we're going to reuse code from this class, such as the take damage and this update. So all the updating is going to be done in this base class. But the specifics of these functions are as you're going to see, are going to be performed in the derived classes. Okay, so again, our mission today, we want our player to move around with keyboard inputs. So let's come back out to Unity here. I'm going to right click, create C# script, and we're going to call this player. All right, we're going to delete all the contents here. You see where it says player : mono behavior. So that's saying right now this class, this player class, is derived from mono behavior. We want to change that to make it derived from our spaceship class. We're going to type spaceship there. And now we want to override that move function so that we call this instead. So we're going to go protected, override vector3 move. And we don't want to we want to totally override the base movement. So we're going to delete that. We need to return a vector3. So we're going to create a movement vector here. So movement vector equals vector3.0. At the end of this function, we're going to return this movement vector. So that fulfills our return here. And so now we're going to take input from the player. So we're going to do if input dot get axis horizontal. Actually, you know what? I take this back. We don't want an if on this. I'm just going to go say var horizontal input equals input dot get axis horizontal. Var vertical input equals input dot get axis vertical. So then we want to take our movement vector. And you notice here we don't have access to our movement speed. So we're taking our input and we want to multiply it by our movement speed. And we want to multiply it by time.delta time. But you see here our move speed is this private field, so we don't have access to it. So let's make this accessible. So get movement speed. Sorry. Public float, get movement speed, turn m move speed. And over here in our player, we can do get movement speed. Similarly, we're going to do movement vector.y. It's our vertical input. Let's get movement speed times time.delta time. Just a quick word on these access modifiers like public, private, and protected. I don't expect you to, if you're brand new to coding, to totally understand when and where to use these different ones. And I don't necessarily want to get into all that right here. I think it's probably would just be confusing. Just keep in mind, as a rule of thumb, you want the least amount of access as possible. In other words, private. So because these are private fields, I can't access them anywhere else. These properties here. That's why I had to create this function for getting the movement speed. And you might think that's kind of tedious, right? If I just made this public, I could just call m movement speed instead of doing this get movement speed, and that might seem convenient, and it is, convenient. But just as a rule of thumb for making clean code, you want to limit the access as much as possible, because you want to make sure that by making this private, it means that only this spaceship class can ever do anything with this movement speed. It can only, if movement speed ever changes, it's because this spaceship class changed it. Same with this health, this max health, and this current health, and it's the alive or dead state here. And that makes things easier to debug and just easier to understand. As your project grows and more stuff is happening, let's say I find my spaceship is blowing up out of nowhere, and I want to figure out, well, why is it suddenly becoming not alive anymore? And it's not something obvious like it's getting shot. Then, because this is all private, I know that it's got to be coming through this spaceship class. But if this was public, that means any other class anywhere else in the project could be setting it. And that makes it a lot harder to track down and understand what's going on. So again, there's a lot of theory and design that goes into this. And I don't want to go into all that. But just as a rule of thumb, let's say, you want to make your access as limited as possible. When we say things are protected, that's just saying no outside class can touch this, but any class derived from this base class. So I had to make this protected because I'm going to be overwriting it in my derived class of player here. So that's where protected comes into play. Okay, so that's an aside. Back to our game. Let's come back out here. And let's drag our player script that we just made onto the player parent. So I have player parent here selected. We're looking at the inspector, and I just dragged this player script over there. And we should be ready to go. I'm going to hit Control S to save. And you can see if I hit up or W and A or up and down arrow on the keyboard, I'm going to go up and down. If I hit, W or S. If I hit D or A, I'm going to go left or right. And the same with the right or left arrows. So this is all working. Let's tweak this movement speed because this feels a little on the slow side. Maybe make that 50 and see how that feels. Now this feels a little better. Now, as you can see, there's nothing stopping my spaceship from just totally leaving the barriers here of the screen. So the next thing we're going to want to do here is put a stop to that. We want to make it so our spaceship stops at the edges of the screen. Up, down, left, and right edges. There's a number of ways we could do this. We could put colliders on the edges of the screen to make our ship not go past them. But I think what we're going to do instead is just check for where the position is relative to your screen size. Okay, that actually worked on the first try. That wasn't crazy. Okay, so let's go over what we did here. So what we did here is we took the position of our spaceship in world space. So world space would be, if we go into scene view, we have here we can see our ship is at -60, 0 on the Y, and 50 on the Z. That's in world space. So that's everywhere in this world. That's different than screen space. So in this game, our screen space is the pixels from the top left-hand corner of the screen to the bottom right-hand corner of the screen. So you can think of the top left is the pixel coordinates of like 0, 0. And then the bottom right-hand corner of the screen, the pixel coordinates of however big our screen is, our screen width, and our screen height. So what we're doing here is every frame when we move, so we get our new movement position. Before we move, we're storing our previous position. Then we do the movement. Then we're translating into screen coordinates where our ship is on the screen. If it's less than 0, so that would be if it's, or on the X, I should say. So screen coordinates.x, less than 0. So that would mean if it's too far to the left, basically. If it's so far to the left that it's off the screen, then we substitute in our previous position for the X value of our previous position. So basically, we can't move any further over to the left. And then, at that same token, if our screen coordinates, the X value of our screen coordinates is greater than the width of the screen, again, we substitute in our previous X coordinate. And then, same thing for the Y, except now we're looking at up and down. So we're looking at the screen height. And we're substituting in our previous position's Y. So that will keep our ship within the bounds of the screen. So for now, that's going to keep our ship within the bounds. As you can see, I can keep holding left and up, and we're just going to get, we can only go so far. And that'll work just perfectly for us. Okay, again, Control S to save. Okay. So one last thing I want to do, and this is just kind of flavor. Let's make it so that if we, so that's probably up here. If we move up, if we move up, let's pitch our spaceship up a little bit, just rotate it a couple degrees up, so it kind of looks like it's moving up. And if we're moving down, we're going to pitch it down. So let's look at our movement vector that we get outside, that we get returned from our move. So if we do movement vector, and we're looking at the y, if it's greater than 0, we want to rotate. Let's think about that for a second. Else, if the movement vector.y is less than 0, we want to rotate a different way. And else, if the y is in fact 0, as in we're not moving up or down, we're going to return to the center. Okay. So what we want to do here is, just to briefly, so you understand what's going on here, we want to make it so that if you're moving down, our spaceship does this a little bit. Maybe pitches down like 15 degrees as you're moving down. As you move up, we're going to pitch up 15 degrees. So negative 15 on the X here. And when you go to center, when you don't move at all, we're just going to level out at 0. So we're going to make a couple variables here. We're going to say private const note C pitch up value is equal to negative 15. Private const float C pitch down value 15. And then we know 0 is to normalize. Okay. We'll also have like a speed for that too. Okay. So let's talk about how do we pitch up here. So we're going to transform.rotation equals quaternion.lerp. So we want our current rotation. Our Euler value for our desired rotation. And then that. Oops. Pitch up value, not pitch value. And then for pitch down, we're going to do something similar. Except here is going to be our pitch down value. And then to return to center, we're going to do 0. Okay, so a quick explanation of what's going on here. And maybe I should check to see if it actually works before I explain it. Let's do that. So we're pitching correctly. Oh, you know what the problem is our y. We have our y going to 0. Our y actually needs to be 90 here. And let's put that into a const. Private const float C y rotation value equals 90. Okay. So why am I putting these numbers into constants here, like variables, instead of just writing the number? So generally, that's another best practices in coding thing. You want to use variables or constants in this case where you can. You don't want, if you just have numbers outside of 0, I think 0 is acceptable, but if this is just 15, we call those in programming magic numbers, and you don't want magic numbers. They're called magic numbers because a lot of times you look at some code and it'll just have a number here, and that becomes very hard to understand what that's doing. Whereas I have this variable that says pitch down value. You can look at that in a second and understand, oh, this is the amount you're pitching down, basically. So it's much easier to read the name of a variable rather than some random number. So yeah, just another best practice there. Okay. So now that we've appropriately set our Y, so now we have this little cool pitch movement here. And then when we don't move at all, we go back to center. So yeah, I think that looks pretty good. So I think that'll probably do it for today's tutorial. This actually feels pretty good. Yeah, so again, the code's in the GitHub and the link in the description. You can go ahead and download that, and that'll show you all the code that we wrote today. And let me know if you're following along and how that project's going. Let me know if you have any questions or you need any help. And definitely reach out to me and I'll help you out. Leave a like if you feel so inclined. If not, that's cool too. And I'll see you next time when what will we do next time? I don't know. Let's do shooting. We'll do shooting next time. Thanks.